Children, today we will learn about elimination reactions of alkyl halide, also known as beta elimination reactions. We will take one example, that is ethyl chloride. When it will react with alcoholic KOH, then hydrogen and halogen both are removed, two sigma bond are break and one pi bond is formed between carbon-carbon, that is alkene is formed and hydrogen halide is formed as byproduct. Now why this is also named as beta elimination reaction? The carbon atom on which halogen is bonded, this carbon is known as alpha carbon and the adjacent carbon is known as beta carbon. In elimination reaction of alkyl halide, halogen is removed from alpha carbon and hydrogen is removed from beta carbon. Due to this removal of beta hydrogen, these reactions are known as beta elimination reaction. Beta elimination reaction of alkyl halide was studied by Alexander Jetser, and he proposed a rule that is also named as Sedgwick's rule. According to this rule, during beta elimination reaction of alkyl halide, more substituted alkene is formed as major product. More substituted alkene, that we can say alkene that is carrying more alpha hydrogen, or more alpha hydrogen is more hyperconjugation, more number of resonating structure. As number of resonating structure increases, stability of that alkene increases. So Sedgwick rule states that more stable or more substituted alkene is formed as major product. We will learn this rule with the help of some examples. We are taking the first example, that is 2-bromopentane. This is our halogenated carbon atom. This halogenated carbon atom is alpha carbon, the terminal carbon is beta dash carbon, and the carbon atom that is in center, this is your beta carbon. When this 2-bromopentane is treated with alcoholic KOH, first this CBr bond will break due to difference in electronegativity. Br minus, it will take away the electron, that's why it will result Br minus, and carbon will carry positive charge. So as you can see, we will get carbonium ion. This carbonium ion is 2 degree, as the positively charged carbon atom is directly bonded to 2 carbon atom, that is beta dash carbon and beta carbon. Now this positively charged carbon atom will ask for the electron to the adjacent carbon. So 2 adjacent carbon atom are there to this positively charged carbon atom. If hydrogen is removed from beta dash carbon, then we will get H plus is removed, then we will get carbon atom will carry negative charge. Electron will move from negative to positively charged carbon by forming pi bond, and it results 1-pentene. Double bond is formed at terminal position. Similarly, if hydrogen is removed from beta carbon, that is central carbon, then we will get, due to removal of H plus, there will be negatively charged carbon atom, and electron will move from negatively charged carbon atom to positively charged carbon atom by forming pool of pi bond, and we will get the position of the double bond at center, and our product is 2-pentene. Now as you can see in both the product 1-pentene and 2-pentene, we have circled this double bonded carbon atom. Now in first part, this double bonded carbon atom that is bonded to 2 carbon atom, 2 substituent are there on double bonded carbon atom. In first case, this is your alpha carbon. Double bonded carbon atom is your functional group carbon atom, and this adjacent carbon atom is alpha carbon. So this is CH2, your alpha carbon, and the second terminal, again double bonded carbon atom, is bonded to CH3. This is again your alpha carbon. Number of hydrogen on alpha carbon is alpha hydrogen. Now we count number of alpha hydrogen terminal. 1 alpha carbon, 3 alpha hydrogen center, 1 alpha carbon, 2 alpha hydrogen, so total 5 alpha hydrogen. So in this way we will get 5 resonating structure from 2 pentene. And in second case, that is 1 pentene, we have circled a double bonded carbon atom. There is no carbon to that terminal carbon, so there is no alpha hydrogen, no alpha carbon. But the center carbon atom is directly bonded to one carbon, and that one carbon is carrying 2 alpha hydrogen. So only 2 resonating structures are formed. So this structure, due to more number of resonating structure, that is 2 pentene, is formed as major product, and second one is formed as minor product. This is Sadjeff rule. Next example that we can take, that is isobutyl bromide. When it is treated with alcoholic KOH, this CDR bond will break and we will get isobutyl carbonium ion. Carbon atom that is carrying positive charge is directly bonded to only one carbon. So it is 1 degree carbonium ion. This 1 degree carbonium ion, by hydrogen rearrangement, shifting of hydrogen, the adjacent carbon to the positively charged carbon atom is having one hydrogen atom. This hydrogen can shift to this positively charged carbon atom, that is CH2, and it results tertiary butyl carbonium ion. This is 3 degree carbonium ion, more stable as compared to 1 degree carbonium ion. Now this positively charged carbon atom is directly bonded to 3 carbon atom, and these 3 carbon atom are identical, that is methyl group. So each is beta carbon, each is carrying beta hydrogen. So anyone can remove one beta hydrogen and our product is formed, that is 2-methyl propene. Only one product is formed. Next example that we are taking is neopentyl chloride. This is neo group, 5 carbon atom, 1 quaternary carbon is there. This is neopentyl group, neopentyl chloride. Alcoholic KOH, this CCl bond will break and we will get neopentyl carbonium ion. The positively charged carbon atom is directly bonded to only one carbon. So the type of carbonium ion or intermediate is 1 degree. This 1 degree can be converted into more stable carbonium ion. 1 degree carbonium ion is least stable. So by adjacent carbon, that is positively charged carbon atom, adjacent carbon is directly bonded to 3-methyl group. Now methyl group, CH3 group, can rearrange. This CH3 group will shift to the positively charged carbon atom, and by this shifting of CH3 group, we will get this stable carbonium ion, that is 3 degree carbonium ion now, because the positively charged carbon atom is directly bonded to 3 carbon atom. So this is more stable carbonium ion. This neopentyl carbonium ion will rearrange to 3 degree carbonium ion, which is more stable. So more arrangement can be possible in this carbonium ion to result more stable product. Now this positively charged carbon atom, that was your functional group or substituent carbon atom, halogenated carbon atom, is directly bonded to 3 carbon atom. 2 carbon are methyl, so can be named as beta carbon, and one central carbon atom, that is CH2, can be named as beta dash. Now, if hydrogen is eliminated from this terminal methyl group, beta carbon, then position of the double bond will be terminal. If the position of the double bond is terminal, we have blocked this double bonded carbon atom as shown. Now the double bonded carbon atom is bonded to methyl and ethyl group. This is your double bonded carbon atom. Functional group carbon atom, the adjacent carbon is alpha carbon, 3 alpha hydrogen. Second one is again alpha carbon, 2 alpha hydrogen. So total number of alpha hydrogen 5. So 5 resonating structure, 2 methyl butene. If hydrogen is removed from beta dash carbon, then position of the double bond is center. It is centrally located double bond. So name of the compound is 2-methyl butene. We have again blocked the double bonded carbon atom. Now the double bonded carbon atom is bonded to 2-methyl group, and the second one is again bonded to 1-methyl group. So there are total 3 methyl group carrying each 3 alpha hydrogen. So in overall 9 alpha hydrogen, 9 resonating structures, so more stable. So 2-methyl butene is major product by elimination reaction of neopentyl chloride. Now we will take elimination versus substitution reaction. SN versus elimination reaction. These reactions depends upon first, nature of alkyl halide, second, size and strength of nucleophile, solvent nature, stability of intermediate. These are the some factors. We will understand these factors with the help of some examples. Children, always remember that if we take 1 degree halide, then it will go for nucleophilic substitution reaction. And if it is 3 degree halide, then it will go for elimination reaction. We will not consider nucleophile. It is only 1 degree halide, substituted product is obtained. And if it is 3 degree, eliminated product is obtained. For example, if I take tertiary butyl iodide, this is 3 degree halide, it will go for elimination reaction. What is the reason for this elimination reaction? We will take first ethoxide ion. This is simple nucleophile. It is not bulky nucleophile. The nucleophile that is having steric hindrance, it is not like that. So when it will react with this, first the Ci bond, carbon halogen bond will break, and the intermediate formed is 3 degree carbonium ion, that is shown in this slide. This 3 degree carbonium ion is more stable, more number of resonating structure due to 9 alpha hydrogen. So due to this more stability of this carbonium ion, more rearrangements are possible within this molecule. So it will ask for the electron to the within molecule atoms, that is 2 methyl group are there, and each methyl group is carrying beta hydrogen. So beta hydrogen can be removed, and the product formed is 2 methyl propene, that is eliminated product. And the extracted proton from beta carbon will combine with the nucleophile, and the second byproduct is ethanol, and salt is formed. We have written that is Cl minus. It will form in form of salt. The same example we will take, that is tertiary butyl bromide this time, but we have changed the nucleophile. This is your tertiary butoxide ion. This is bulky nucleophile, 3 methyl group. Steric hindrance is there. It is bulky nucleophile. It is not simple nucleophile like ethoxide ion. This time again, irrespective of the nature or size of the nucleophile, this tertiary butyl bromide will ionized, will break to give tertiary butyl carbonium ion within the molecule. As I've explained earlier, rearrangement is possible and the product formed is 2-methyl propene, abstract of proton from beta position, and that proton will combine with our nucleophile and tertiary butyl alcohol is formed as byproduct along with salt. Now we will take examples of primary halide. Primary halide or 1-degree halide will go for substituted product. We will take examples for this type of reactions. 1-degree halide, we have taken ethyl chloride. It will react with simple nucleophile, that is ethyl sulfide C2H5S minus with SN2 reaction. When the reaction will proceed, then transition state is formed. In this transition state, C-Cl bond will start weakening and new bond between sulfur and halogenated carbon atom will start forming, and this transition state will further proceed to the product formation, that is thioether. This halogen is substituted by nucleophile and the byproduct is halide salt. If I change the nucleophile from simple to bulky, that is isopropoxide, and this time we have taken, when it will react with 1-degree halide, that is ethyl bromide, then CBr bond will break and new bond will form between oxygen of bulky nucleophile and halogenated carbon atom, and it results this transition state. This transition state will further proceed to product formation, that is ether. Name of the ether is 2-ethoxypropane. Longest chain is 3 carbon atom chain, and OC2H5 group is bonded to number 2 carbon atom, that is 2-ethoxypropane along with bromide ion. So we will conclude for 1-degree halide and 3-degree halide, that is 1 degree for substituted product and 3-degree halide will go for eliminated product irrespective of the size or nature of the nucleophile. But if we take 2-degree halide, then there will be competition between elimination and substitution reaction. So if 2-degree halide is there, that will carry beta hydrogen. If it is attacked by a simple nucleophile, then it will go for SN reaction, and the nucleophile, if it is bulky, then it will go for elimination reaction. For example, we have taken 2-bromopropane. Halogenated carbon atom is directly bonded to 2 carbon atoms, so it is 2-degree halide. And this is our halogenated carbon atom. When it is attacked by simple nucleophile, that is ethoxide ion, this CBr bond will break and replaced by ethoxide ion. 2 followed SN reaction and the product formed is ether, that is 2-ethoxypropane. And if the same reactant, that is 2-bromopropane, will react with tertiary butoxide ion, that is your bulky nucleophile now. This bulky nucleophile is carrying 3-methyl group, that is steric hindrance is there. When it will go for substitution reaction, 2-methyl group are already with our 2-bromopropane, and these 3-methyl group, there will be steric hindrance, crowd will increase. So this nucleophilic attack to the halogenated carbon atom is not feasible. So instead of attacking as strong nucleophile to the halogenated carbon atom, it will abstract proton, that is from beta carbon, and beta elimination is followed, and the product formed is propene along with tertiary butyl alcohol and bromide ion. So in simple way we can conclude 1 degree halide SN reaction, 3 degree halide elimination, and if it is 2 degree halide then it will go for, in case of simple nucleophile, SN reaction. We will use this reaction in preparation of ether. When we will discuss preparation of ether, then we will use the same reaction from 1 degree halide and attack of nucleophile to ether preparation. The simple nucleophile will go for SN reaction, and bulky nucleophile, if it is, then it will go for elimination reaction. Now we will take reaction of alkyl halide with metal. First we will take reaction with magnesium metal. Alkyl halide reacts with magnesium metal in presence of inert medium like ether. Then the compound formed is Grignard reagent. There is direct bond is formed between carbon atom and metal atom. Such compounds are known as organometallic compound. Organo stands for carbon compound and metal for magnesium. Organometallic compounds. The name of the compound is ethyl magnesium chloride. This ethyl magnesium chloride can be written in simple form, that is RMgX, where this RMg bond is covalent in nature, but there is electronegativity difference between R group, that is carbon, and magnesium. So shared pair of electron will remain towards carbon atom, which one is more electronegative than electropositive metal atom. So there will be ionic character generated in covalent bond. MgX bond is ionic in nature. So this is alkyl magnesium halide. This compound Grignard reagent is very important for organic preparation, organic conversion reaction. We will use this compound. The compound is prepared and stored in inert medium like ether, because if there is simple water vapor if are present, then this water vapor will react with this RMgX. R that will carry negative and magnesium will carry positive charge, as I have explained the nature of the bond. So this RMg bond will break and water will break in form of H plus and OH minus. R minus will react with H plus and the form compound is hydrocarbon, that is RH, along with the byproduct, that is MgXOH. If our compound is ethyl magnesium chloride, in presence of water it will prepare ethane along with MgClOH. So this is the reaction with magnesium. Next we will take reaction of alkyl halide with sodium metal. This reaction is Wood's reaction. We have studied about this reaction in 11th standard. This is ethyl chloride reacts with sodium metal in presence of ether. 2NaCl will break, formed as byproduct, and the product formed is CH3, CH2, CH2, CH3, that is butane. So in Wood's reaction, similar alkyl halide will react with sodium metal in presence of ether, that is taken as a solvent. Next we will take Fittig reaction. When aromatic halide we will take as reactant. This is C6H5Cl chlorobenzene reacts with sodium metal in presence of ether. The product formed is C6H5, that is biphenyl, along with byproduct 2NaCl. If these two alkyl halide that we are taking as reactant are different, that is Wood's Fittig reaction. CH3Cl reacts with sodium metal along with chlorobenzene, then the product formed is toluene along with sodium chloride. If we take ethyl chloride, react with chlorobenzene with sodium metal in ether, the product formed is ethyl benzene along with sodium chloride. So this is reaction of alkyl halide with metal.